Welcome back. Now that we've worked through level shifting and infrared obstacle sensors, we'll move on to infrared line sensors. And then later in the activities for this lesson, you'll get to use both types of sensors along with level shifting in a project. In this video, you'll learn how to work with an infrared line sensor, which will come in handy once you're working on the robot in level D. Now, I've brought my friend Marvin back here to show you how the line sensors will be mounted to the chassis during lesson D6. They're the two sensors on the bottom in the center. They're the black ones. And in a few minutes, it should become clear why they are placed in that position. Now, as with the obstacle sensor we just talked about, there is one line sensor included in your level B kit. There are two in the level D kit, so you can mount those to the robot while still having the one from this kit to use in other projects. Okay, let's jump in and learn how to use a line sensor. An infrared line sensor can be used to detect the difference between dark colors and light colors using infrared waves. This can allow a robot to perform an activity referred to as line following, where it can follow a black line, often created by using black electrical tape on any light-colored surface. The robot can follow the path created by the tape without any intervention from the user, using only the IR line sensor input and the program. The infrared line sensor operates almost exactly like the infrared obstacle sensor. The only difference is that the emitter and receiver have been relocated from the front to the bottom of the board. Since the line sensor is always close to the surface it's detecting, a plastic shroud is installed around and between the emitter and receiver to limit emission and detection to just those ends of the components, which enhances the accuracy. The line sensor operates using the infrared properties of different colored objects. Black objects absorb most of the infrared waves they receive, so they have a low level of infrared reflectance. White objects reflect almost all the infrared energy they receive, and so they have a high level of infrared reflectance. As objects vary between white and black, so will their infrared reflectance, lighter colors having higher reflectance, darker colors having lower. The sensor uses this difference in reflectance to determine if it's positioned above a black or white surface. The 5-volt output pin is then updated to match the color that is currently being sensed, with low or 0 volts indicating black and high or 5 volts indicating white. If no object is close enough to reflect the infrared, the output will also stay low. Now notice, this is exactly the opposite of the obstacle sensor, where no object detected means the output stays high. The pinouts between the IR obstacle sensor and the IR line sensor are not the same. Even though they both have 3 pins with 5-volt ground and output, these are located in a different order on both devices, so it's critical to ensure that 5-volt ground and output are connected properly prior to applying power to your sensor. Reversing any of these connections will likely cause damage to the sensor and probably to your Raspberry Pi as well. Now, a robot could follow a black line using only one IR line sensor. The sensor would need to be positioned directly above the line, and your robot would have to be programmed to drive one motor at a time. So if white was sensed by the line sensor, the current motor has driven you off the line. The other motor needs to drive until the robot is back on the line. While this would technically work, your robot would have to move extremely slowly to avoid getting away from the line too quickly and getting lost. This is why we provide 2 line sensors in the level D kit. Adding a second sensor allows you to watch both sensors, and if either sees black, then the robot will be programmed to turn away from the line. This allows the robot to sense a larger area so your robot can follow the line faster without getting lost. Using 2 sensors is the most cost-effective way to make a robot reliably follow a line, but continuing to add sensors can enhance the robot's ability to follow the line quickly. Some line sensing packages, like the one pictured here made by Sunfounder, have as many as 8 infrared sensors. Now, this can greatly increase your robot's ability to know the exact position of the line. However, your program would have to be much more complicated to process and act on the data from all 8 sensors. And frankly, we wouldn't do that to you. Building the robot in level D is meant to be a complicated and challenging project. It is. But it's also meant to be one that you will be able to tackle by the time you've completed level C. To keep the required programming at a reasonable level for each stage of your learning process, you will learn to install configure and code for one line sensor here in level B, and then 2 line sensors later in level D. Okay, just for fun, let's take a moment to preview level D and talk about how you will use these sensor skills you're learning here in level B to build and code a fully mobile robot. Okay, so now that you understand how both an IR obstacle sensor and an IR line sensor work, take a look at Marvin again and think about the sensor placement you see here. Okay, so the IR obstacle sensors here on Marvin are mounted on the outside edge of each side of the chassis. Why would we place them there? The type of obstacle sensor in your kit is good for sensing objects that are fairly close to the sensor. So this type of sensor won't tell you how far away an object is, only that something is near the sensor. Placing them right by his wheels is basically using them to protect him from running over something or crashing into a wall that's close on one side or the other. Okay, so let's look at the placement of those 2 black line sensors in the center of the chassis. Thinking back to what we've talked about in this lesson, does this placement make sense? If we want to program Marvin to follow a line that's made of black electrical tape, which is about 3/4 of an inch thick, then having these 2 sensors centered on the chassis and a few inches apart sets him up to stay relatively centered on that black line. Okay, so the obstacle sensors only sense objects close by, and the line sensors are only looking for contrast. What if you need your robot to detect objects that are further away? Ideally, the robot needs time to detect an upcoming object and make a decision via programming whether to stop or turn to avoid the object. This decision making would be way simpler if the robot could detect how far away the object is, right? So detecting objects more than 10 inches away and measuring the distance to those objects, we would want to use an ultrasonic range sensor. That's the eyes looking sensor that you see front and center here on Marvin. I'll show you how to work with one in the next lesson. Okay, before you move on to the next video, let's take a few moments and review the concepts we discussed in the last 3 videos. First, digital signals operate at high and low, but not every device has the same voltage for its high signal. The Raspberry Pi uses a high signal of 3.3 volts. Many components use a high signal of 5 volts, and it's very important never to attach a 5-volt device directly to the Raspberry Pi's GPIO pins. The integrated circuit included in your Level B kit allows input signals of 3.3 volts to be shifted to 5-volt outputs, and 5-volt inputs to be shifted to 3.3-volt outputs, and this makes it possible for those 5-volt components to be used with a 3.3-volt Raspberry Pi. And then we discussed how an infrared obstacle sensor uses infrared waves to determine if an object is near. The 5-volt output line is level shifted down to 3.3 volts for connection to the Raspberry Pi and operates as a low active output. That means that when the pin is high, no object is near, but when the pin is low, an object has been detected. Now remember, the obstacle sensor has a fairly small range, but is useful when you need to detect objects that are close by, like when you're trying to prevent your robot from running over something with his wheels. And then in this video, we looked at infrared line sensors. These sensors operate similarly to the obstacle sensors, but the sensor position is on the bottom and they do have a different pinout, so be very careful when placing them in a circuit. While you'll learn to work with a single line sensor in this level of the program, later in level D, you'll work with 2, which will allow the robot to effectively follow the line while keeping the complexity of the coding reasonable. Okay, go ahead and move on to the activities for this lesson, where you'll get a chance to work with both the obstacle and line sensors, which will give you a chance to also practice your new level shifting skills.